without VPNs, Uptycs and JA3, sponsored by Uptycs. My name is Jessica Gallis-Sands, and I will be moderating today's webcast. Today's featured speakers are Guillaume Ross, Principal Product Manager at Uptycs, and Dave Shackelford, SANS Analyst, Instructor, and Course Author. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be made available for viewing and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Dave.
Awesome. Thank you so much for that intro. And hey, thanks everybody for joining us on a really interesting journey here. And this particular topic is, interesting probably is just the beginning of this, because what we're starting to see is this crazy evolution of just how people are working and the nature of where they're working from and the types of systems they're using to perform that work and everything in between. But there are all of these really sort of compelling realizations coming out of that security folks are starting to come around to, meaning, hey, wait a minute, what kind of endpoint security do we have across everything? Is it giving us the visibility that we need? Is it giving us the protection that we need? And in addition to that, what are some of the things that we might have been relying on very heavily in like a core data center setting that we don't even have anymore? Because now, hey, maybe people aren't connecting back to the data center. And that's been a very consistent trend and theme over the past, certainly several months, but I would even argue it's been going on longer than that. The move away from a traditional hub and spoke sort of model that people have been using, and by hub and spoke, obviously I'm talking about VPNs or some form of dedicated secure remote connectivity option where you've been bringing everybody back to the ranch, as it were, and then from there they can sort of go off and do what they need to. But especially with the evolution of things moving to cloud, more cloud service use by end users where, really to get their job done, why would they need to connect back to the core data center for a lot of those things? That has driven this, sort of set of realizations, some very positive. So, hey, we're untethered, we're, freedom. On the other hand, some really big challenges are starting to crop up. And I'll mention sort of the nature of at least one of those here. So let's go on ahead to the next slide. And this is just an introduction as to who we are. I'm Dave. I'm going to be joined by Guillaume in just a few minutes. And so let's go to the next slide where we'll actually kick this whole thing off. So the whole idea of monitoring in many enterprise organizations, and coming from this background myself, I feel this one pretty strongly, has honestly been very network centric. So we've really relied on network, sort of like core network, blinky things in the racks to give us the visibility we need and really tell us what's going on. And this dates all the way back for several decades, right? We've been doing so since, I guess somewhere in the 90s, maybe late 90s, early 2000s. This became a definitive trend and then, sort of arguably a best practice thereafter. So pretty much any enterprise out there worth its salt with regard to security maturity has in fact had some forms of network security monitoring in place. Now, coinciding with that, naturally, we've seen that attackers have gotten a lot smarter, and they've looked for ways to really morph their behaviors into things that aren't quite as recognizable, right? So they're looking for ways to blend in. They're looking for tactics, techniques, and controls that they can leverage to really sort of get away from the obvious, right? Oh, yep, your IDS picked them up. Oh, you got blocked by the IPS or the firewall or some other sort of monitoring solution. So one of the big trends that we've seen, I'd say, sharp increase percentage-wise in the past, let's call it decade, really. It's been going on longer than that, but definitely a sharp trend in the last decade, has been the move towards encrypted communications by criminals and malicious actors. And the thing is, it goes even vastly beyond that. We're starting to see that more and more traffic is encrypted, not just by these sort of malicious actors, but also by, frankly, everybody. And in fact, the majority of traffic today on the internet is in fact encrypted too. So let's go on ahead to the next slide, and I'll just sort of highlight some of these points, because I think if you go back and look at sort of the drivers, and I didn't even try to just fill a slide full of all the various sort of incentives or regulatory requirements and what have you that have really necessitated or driven the push towards encrypted communications in the past 10 to 15 years. There's a laundry list of them. There's been a lot of industry sort of impetus to go there. Let's just make sure that the privacy and security of everybody's communication is paramount. We really sort of highlight that. If you're looking at just maybe the theme in the community, if we want to look at things that way, okay, that's a theme, right? Protecting communications has been a theme for quite some time, but it's also been driven by some of the major technology firms, Google being a big one. We've seen the same thing for mobile with Apple, and certainly some others out there too. We've really watched as there's been this sort of creeping trend towards, well, encrypt everything, truthfully. And PCI, as just an example of this, came out and said, hey, we're not even going to go so far as to say you have to be encrypted. We're going to go beyond that and dictate or mandate to a degree the level of enforcement within encryption, particularly for TLS or SSL types of communications. And everybody knows that story today. So here it is, it's 2020. I don't think we need to go down the rabbit hole of versions of SSL that led to TLS, which are now sort of cropping up and bleeding into the newer trends of TLS communications, which is definitely changing things. That's a whole topic in its own right, is TLS 1.3 and what it's bringing about for us. But the bigger point is PCI came out and said, look, we're not going to accept a control that you're putting in place with SSL TLS unless it's version X, Y, or Z. And that's going to be a continuous trend going forward. So all this really kind of brings us back to the bigger point of encryption is here to stay, the sort of normal state of things, as it were, and the future normal state is going to be encrypted traffic. Let's go to the next slide. And maybe just to sort of underscore or illustrate this, right, I think Google does a pretty good job of just highlighting what they're seeing out there with regard to not only their own browsers, but even their own types of communication devices. Those guys have a pretty big chunk of that market space, right? With Chrome, of course, and with Android devices, and really just what's hitting them and their various Google web properties. Of course, Google, just the search engine being the biggest one, but that is a vast amount of the internet, right? Think about the majority of people out there. How many people's homepage is Google? Right, so they see a lot, and that means they see a lot of browsers, they see a lot of trends, and what they've seen is a pretty sharp rise over the past, again, decade. But this particular chart, which is readily available on Google's site, over the course of the past 6 years, going up to pretty much present day, I mean, you can see where those numbers are. I mean, it's coming in at upwards of about 85 to 90-ish% of encryption across all of the various Google types of sites and services. And if we go to the next slide, I think they sort of highlighted this other trend of just, hey, what else is going on in terms of just the requests coming in. Everything coming into Google across the spectrum of the world is pretty much looking encrypted too. So you can see, I mean, it's almost 100% encryption coming from India. And, they got a bunch of other different countries here, but, the United States, United Kingdom, even though they're on the sort of right-hand side of this graph, it's still upwards of 90%. So you're seeing a lot of encryption just unilaterally be applied, not only in just day-to-day communications, but even across all of the different types of web services in use out there. Great. So we've established the fact that encryption's here to stay. What the heck does that mean for us? So let's go on and sort of move to the next slide and sort of bring it back to the security and the defending side of things and say, well, what are we trying to get out of traffic in the first place? I mean, if you really try to boil it down and say, as far as like day-to-day effort is concerned, if you're a network security analyst, or if you're a security engineer, operations person that's looking at the network traffic, what are you trying to get out of that within a traditional enterprise setting? And this is definitely not a complete list. I didn't even try, but I, thought about the big things that I hear consistently from students in my classes and, clients of mine as a consultant. And of course, it's the, classic malicious content, which might be exploits or malware. I mean, that's a pretty significant chunk of it, but it's sensitive data that might be, leaving the environment in an exfiltration effort, or just even exposure accidentally, which of course brings up things like data loss prevention. But hey, again, to, have data loss prevention, you got to see the content and inspect it. Thus, there needs to be some degree of visibility into that traffic. Things like command and control traffic, and that goes back to the mid-2000s when, the folks that used to write worms figured out that they could start writing bots instead and manage them. Wow, what a, shocking paradigm. But along with that paradigm comes command and control. So we've been really paying attention for easily 15 years to the concept of command and control traffic and what it looks like, and trying to find it desperately when it shows up on the network, because what does that indicate? You don't have command and control traffic without some form of compromise. And so this concept of things beaconing out to sites or some other sort of endpoint compromise indicators through the use of traffic monitoring and visibility, all of this rolls back around to me knowing or us knowing what's in the traffic in the first place, or sort of what's happening behind the scenes. Let's go to the next slide, because this is beginning to be a much bigger problem right now, right? The challenge of encryption. And encryption is, hands down, a double-edged sword. On the one hand, it's great for protecting privacy and content, but on the negative side, from a security visibility standpoint, we've started to really see some big challenges with decrypting that traffic. So number one, just the cost of it. For any of you guys that have ever actually tried to implement large-scale like packet brokers or SSL termination technologies for interception and evaluation, none of them are cheap. And it's not necessarily just financial cost, it's operational cost and overhead just in terms of getting it in place and maintaining it. Performance degradation can go along with that. And nobody loves performance degradation. So the minute you spin up some form of interception, okay, well, that's great, but is it slowing everybody down? And if that happens to a certain extent or degree, well, you're going to have problems that are totally different. Performance definitely leads to unhappy users or customers or both. Privacy concerns, that's like the Captain Obvious one. So you can see everybody's stuff. Nobody really likes that concept of the big brother. And now you've even got new headaches in place with the onset of TLS 1.3 because of the nature of how it manages the handshakes and keys. So you don't have the concept, you have a session key now, you don't have the ability to basically get a key and sort of load it up in some sort of an interception device with TLS 1.3, which is definitely the trend that is well on its way. So, today mostly still 1.2 and maybe even some 1.1 sort of out there in the sphere of things, but TLS 1.3 is on its way, and we really haven't completely figured out ways around that easily, at least. So all that said, that's great. It is what it is, but I'll take it even one step further. You may not even be able to do any sort of interception due to where the users are. So if you're not bringing everybody back, the whole concept of this webcast being, you've got these untethered users that are out there, and they're far flung all over the place, and you're trying to move away from that hub and spoke of VPN. You might have to think completely differently about really what's going on there without even the sort of core data center infrastructure and concepts in place at all. So let's go to the next slide. And that next slide really kind of brings us to this idea of how we might be able to at least sort of take a step in a different direction and think about this from a new viewpoint, right? If you know that you've got all these users, using their browsers and doing all these different things, well, what can happen here, right? So, how can we really use the concept of things like TLS fingerprinting, meaning the encrypted traffic is still encrypted, right? We're not trying to decrypt it necessarily anymore, but we can look at some attributes or factors related to the TLS implementation and use to discern some things. Again, going back to those things we want to know, I could see the type of client that's in use. Well, that tells me a lot because, if a non-standard client shows up, right, it's not a browser. So it's not Safari or it's not Chrome or it's not, Internet Explorer, Edge. It's not one of these things that we know are the approved types of browsers, especially on managed devices. in the organization where you should have the expectation of knowing that. Okay, that's interesting. You might see some evidence of attacker persistence in terms of the client that's in use, because maybe they're basically spinning up some sort of faux tunneling mechanism that doesn't rely on a traditional client at all, and so you have something that just is obvious as a standalone communication channel from an attack. You could also look for other interesting clients that look like unusual ones for a particular type of device or for a network segment, or maybe domains that the client is trying to access. Well, all of this is possible through the use of TLS fingerprinting. So it's not something that you have to have full introspection into the traffic or the content of the traffic to even be able to wrangle. So kind of an interesting idea that totally, sort of takes the conversation in a different direction. So let's go to the next slide. And really, I'll just wrap this up by saying, what does that mean for us? Where are we heading with this? I'd say, number one, we need to be cognizant of the fact that the world's changing around us. The dynamic nature of what's going on out there in the technology sphere is sort of leading us to more cloud, more virtual and converged infrastructure, much more sort of rapid fire, dynamic infrastructure being spun up. A lot more emphasis on the workloads themselves versus really relying on controlling the network. We've got a lot more hybrid architecture that's connected across brokering mechanisms and things like that, where, again, you may not have control of that backbone or carrying mechanism for the traffic at all. And I think what we're also going to see, and this is steadily happening, is the realization that we really need to focus more on behaviors, and sort of fingerprinting those behaviors and understanding them more effectively is probably going to lead to a sort of stronger degree of security efficacy, irrespective of whether it's at the network or endpoint level. But given the challenges we're seeing with the network, as we just talked about, we're probably going to be shifting a little bit more towards that endpoint or that workload scenario over time as this encrypted traffic problem really starts to rear its ugly head even more. So with that, I'm going to actually hand things off to Guillaume.
Hey, thanks, Dave, for the introduction on all of these concepts. So what I'd like to do today is, just introduce Uptycs to all of you that are listening, and then we'll look at how we can use a tool like Uptycs to solve some of these challenges. So Uptycs is a platform that allows you to gather information from any type of endpoint, if it's Mac, Windows, Linux, containers, and it is a tool that is primarily in the cloud, meaning you'll get the data even if a machine is not on your corporate environment, right? So that helps when you have systems that are out and about, people working from home, or things running in an external cloud. If you'd like more information, more technical information about Uptycs and OS Query on different topics, I would recommend you check out YouTube for our OS Query at Scale conference that was at the beginning of the year. One of the last times I took a plane, actually. We have a few people there that did some very interesting talks on different topics using OS Query. So if you're interested in OS Query, I highly recommend you check that out. So as Dave said during the introduction, we have a lot of visibility challenges, and the current situation with people confined, working from home even more, kind of sped that up, but it's something that was definitely coming, that was happening anyway. It's just maybe happening a little faster for some companies, and now we have to fix things a little faster than we would have otherwise. But we also have some security opportunities that come with the fact that people are going to be working more and more remotely. Things like lateral movement, for example, become much harder if everyone is sitting at home working behind NAT, right? Like there's no such thing as easy lateral movement using Windows shares and all of that. So we'll look at a few opportunities that we have, and then we'll talk specifically about JA3 and TLS fingerprinting and how we can use Uptycs to detect malicious HTTPS clients without having to centralize all the network traffic. So the visibility challenges. I think Dave went over that pretty well, so I won't spend too much time on that. But definitely the fact that devices are remote makes it so network monitoring is very difficult. It's almost certain that people are going to be on an insecure network from time to time if we're talking about laptops, right? People are going to be working from home. We don't know what other devices are there. People are going to be working from different hotels, airports, and all that. There's no security there that we can rely on. And the solution has been VPNs for a while, right? either a VPN that people have to use at some point if they want to access some corporate resources, or sometimes people are using things like Direct Connect on Windows, which is an always-on VPN. And there's a lot of downsides to these, right? It impacts the user experience negatively. If it's something that is not always on, then you need to remember to use it. Performance might be impacted. There's always the question of, do you allow split tunneling? Well, if you do, that's kind of dangerous. But if you don't, the entirety of the internet traffic of all of your users is now going to be routed through the VPN. And that's something that we saw a lot of people struggle with when they sent a lot of people working from home all of a sudden, right? You don't instantly get all the capacity that you need. And then there's a bunch of other painful things about VPNs, especially when you're traveling, right? You're in a hotel, there's a bad captive portal, but now your VPN is trying to log in and you can't reach a captive portal properly and all these issues. So that's not great. Then we've got the cloud, right? Network monitoring, especially in infrastructure as a service environments, is expensive. It is possible, but there's a bunch of caveats, right? You usually won't get full packet capture. It's usually a different service you're going to need to pay for, and the volumes are going to be huge, and it's going to cost a lot of money. You're going to be able to get some logs of what's going on, especially anything that relates to the cloud APIs, but using these isn't always super simple. And there's so many different cloud services out there that just understanding what you need to do to secure them is very complicated. But if we're talking about virtual machines or containers in the cloud, that means that we do get a layer of endpoint level security monitoring that we already had before, and we can still do it in the cloud. It's just important to have a tool that's going to scale. And then, as Dave was saying, encryption in transit is great for privacy and security. Though malware, I was going to say malware vendors, I guess, yeah, people who make malware include some people that are vendors, I guess, are using encryption, of course, because there's great services out there to be able to get cheap or even free certificates. So why wouldn't you? It's so easy. There's no excuse for anyone not to use TLS on an HTTP endpoint nowadays, including people making malicious use of it. So we're losing visibility. Now, the opportunities that we have related to the situation and these different issues is, we know VPN is impacting user experience negatively. Well, what can we do to replace VPNs and make something that works better? Well, I think the whole zero trust security kind of mindset and using reverse proxies instead of VPNs is actually great, right? You have reverse proxies for the important internal corporate tools that you have. You can expose them on the internet and enforce policies that will enforce two-factor authentication, that can check on the status of the machine before you let people through. And you can even have some policies saying, yes, you can log into the HR platform and see your own data if you're working from an insecure network and maybe an uncontrolled endpoint. But if you work in HR or you're a manager, well, you actually won't be able to see the information about other people's salaries. When you log in like that, you should be on a trusted endpoint before you do that. And that's a much better user experience, and we can actually even increase security with that. Having security tools that work from anywhere is also a big improvement in user experience for the end users, but also for the people managing these systems. So that could be security analysts, could be IT. So think of a situation where your antivirus can only get updated when people are logged into a VPN, right? So someone turns on their laptop, they do some work that might not require VPN, and then they don't have the latest signatures. But also if there's a detection, that detection might not make it back to the centralized console, so the security team won't know about it. So all these tools, you should make sure that you have a way to receive alerts and to keep them up to date using the internet, right? Like it should all be cloud-based, either in your own internet-exposed cloud, or if there are SaaS tools like Uptycs, just make sure that it works for everywhere, from everywhere. And then we can also improve the privacy of some of these things. The way OS Query works is it exposes an operating system as if it was a SQL database, right? So there's over 200 different tables in OS Query, and at Uptycs we leverage OS Query a lot for everything that is endpoint. And that means that you can be very granular about what you're going to read on different machines. Whereas if you were doing TLS decryption, it's pretty invasive, right? So if you're decrypting all the traffic, you will end up with a lot of passwords, session cookies. You'll get a lot of information about the URLs that are being visited, which in some cases you probably don't want or need that level of detail. And it's becoming less and less socially acceptable to gather all that kind of network traffic and decrypt it. Especially in different countries, it's different legally, but also the expectations of employees in different countries around the world are different. So we can improve the privacy as well. And when we talk about zero trust security, I think it's important to highlight the fact that zero trust security is used to protect networks and applications by helping you identify not only the user and authenticate them with things like two-factor authentication, but looking at multiple aspects of the system that's being used, right? So for example, if you were using Uptycs on an endpoint, we've got open APIs that can be used to integrate with your zero trust platform, where you can go and check any different attribute of the machine before you grant a specific type of access. So now let's talk about TLS fingerprinting and specifically JA3. So JA3 was created by Salesforce and is open source. There's the GitHub URL right there. You can check it out. And it's been implemented by a lot of network security tools, commercial ones, but also open source ones like Zeek, for example, formerly known as Bro. A bunch of these different open source IDS type tools support JA3. And JA3 is a standard for fingerprinting TLS. So what happens is when a TLS session is established, and I might say SSL or TLS interchangeably, that just means I'm old, not that I mean specifically SSL version 1. This actually works for all TLS versions up to now. When a session is established, there's the client hello packet that is sent, and that packet is actually unencrypted. And so that gives us a little bit of intelligence about what's going on, right? We see what version of SSL or TLS is being used. We see what cipher suites are supported, what extensions, elliptic curves, and elliptic curve formats are supported. And that's very interesting because if you have a client that is a web browser, a real web browser like Google Chrome, Firefox, that browser will support a lot of different cipher suites because it needs to be compatible with all the websites in the world, essentially. From time to time, there's going to be some new cipher suites that are added, and some old deprecated ones will be removed, right? So if you try to connect to a website with SSL 1.0 in a very insecure cipher suite using the latest version of Chrome, it probably wouldn't work. But anyone doing business on the internet is not going to be using these super old cipher suites because then no one can get to the website. But if you're making malware, you're trying to make that malware as simple as possible, and you're trying to make it small. And that means you're probably not going to support TLS 1, 1.1, 1.2, and 1.3. And you're not going to support 35 different cipher suites, right? You're probably going to pick whatever your command and control is going to run. And that makes for a fingerprint that is very useful because what a browser supports versus what the malware vendor is going to build into a specific small executable or payload is going to be very different. So I'll show how that looks in Wireshark just to give you an example. So let me unlock my virtual machine here. And while I'm going through, if you have any questions, feel free to send them live. We will have Q&A at the end. But if I do see some questions pop up while I'm talking and they apply directly to the subject, then maybe I can even show something live. So here I have Wireshark. I was just sniffing some traffic on a virtual machine just before we connected. And as you can see here, we have a client hello packet right here. So I'm just going to open that up. And as you can see in those headers, we have information about the version of TLS. See here, 1.2. We see how many cipher suites are supported. There's 18 of them. And look at their names, right? Like this is very specific text. If anyone also supported 18 cipher suites, but one of them was different, you'd get a completely different JA3 hash. And then we've got all the different extensions. And the way that JA3 works is it takes all of that information, concatenates it together, and then produces a MD5 hash. So if any single piece in the chain changes, you'll get a completely different JA3 fingerprint. Now, this is most likely a legit client. So what I'm just going to do now is I'm just going to scroll a little bit. I have actually this one right here. Okay, so you see something requested the IP for superlegit.evil.plumbing, which is my command and control server with a very subtle name. And we can see the client hello that relates to that. And right away, we can see that it only supports 6 different cipher suites. So when you're looking at network traffic like that, that's already a pretty good indication that this is a made-for-purpose TLS client. It doesn't mean it's malicious, but it means it's probably not a general-purpose browser. And that JA3 hash that relates to that would be interesting to get. So I'm just going to open up some notes here and just make sure I have the questions in the foreground in case anyone sends anything. And so now what I'm going to do is I'm going to open up a web browser. This is just standard Firefox. And this is kind of a slow virtual machine. So while Firefox is opening up, what I'm going to do is I'm going to create a malicious payload just using standard Metapreader from Firefox. And I'm going to call it Dave's app, right? As if Dave was making that payload. And so this is very standard payload, right? Like a real attacker, if they're using that, they're going to get caught really, really easily. That being said, it's a really good example of a payload that uses HTTPS to communicate. So you see here in my payload, I specified a destination host, port 443, and I'm using a reverse HTTPS type of shell. So this app compiled as Dave's app, I'm going to make it executable, and I'm just going to run it. So in a real scenario, that would be delivered via phishing or some exploit, something like that. But now we've got a payload connecting back to command and control somewhere. And now I'm just going to browse my local newspaper, which is a good test because it's HTTPS and has about 20 million trackers that are also HTTPS. So that's going to generate some HTTPS activity. So my browser is being a little slow here, but it doesn't matter. It's going to start generating some activity. So now I'll go back to a standard web browser on my actual computer. And I'll show you what happens on the Uptycs side. So Uptycs uses OS Query as the endpoint component to it. We also support getting data from sources like AWS, where we have our own connectors. But when data is coming from OS Query, it is from endpoints, it is based on OS Query. So that means we've got hundreds of tables with information coming back from endpoints. One of them is called HTTP events. And in the HTTP events table, we get information about sources and destinations and URLs that are being browsed. So if I ran a new query, just going to create a new query, I'm going to select everything from HTTP events, where the endpoint that is concerned is the machine we were just on, which I called Guillaume Sans demo. And I'm just going to run it like that. All right, so is that a typo or is that the demo gods? I hope it was just a typo. There we go, my query is running. And what you'll see is we have a lot of different fields, right? And for a lot of the connections, they're on port 443 and they're HTTPS, so we know what protocol things are running on, but we don't see what actual URI was being targeted because it's encrypted. So you see every connection that was not encrypted, we have a bunch more information. So what we did, since we already had all that information, was we decided to process the JA3 ourselves directly in that table. So that's something that the open source version of OS Query doesn't have, but we did release a patch for it. So if you're using open source OS Query, you can just grab the patch from our website. And as you can see, this is all the info that's required to compute the JA3 fingerprint, which is right here. So this JA3 fingerprint is a really good way to identify a TLS client. Now, what you can easily do with Uptycs using that same table is, in this case, I'm only going to select a few different fields, and I'm looking for the JA3 fingerprint. And as you can see, there's a lot of connections that seem to be established using that client that has this specific fingerprint. So if I look at this and I see it's connecting to this remote address. So we also have a table with all the DNS queries. So I prepared a little query here where I'm going to select from our DNS lookup events table everything where the answer was this IP address, which I think looks a little bit suspicious. So by doing that, I have this fingerprint, I've got an IP address, and right away I see that the host name that was requested that resulted in that IP address being responded was that superlegit.evil.plumbing. And so now I'm feeling like I'm probably on track. There's probably something that's suspicious about this, right? And maybe I don't know what that fingerprint is yet, but I would like to know where that fingerprint has been seen. So instead of looking only on my machine, I'll look on every machine, but I'll look where the JA3 fingerprint is equal to this one. So this is a meterpreter. Oh, you can't put where, that doesn't work. I can't SQL while talking. And now we can see all the different machines where this specific payload has been seen. And fortunately, it's only on my demo machine. But if this was something that's spreading in your environment, you would have seen that in many different places. Now, that's very reactive, right? And so what we did was we built a very flexible alerting system. So what you can do is, and I'm going to show you a specific example right here, is you can create an alert using a wizard. And so in this case, just before we got on the webinar, I created an alert that would trigger if anyone uses Firefox. So I create an alert, I say, actually, let me just show you what it would look like if I was creating a new one. So I give it a name. Then I specify for what type of result an alert should be raised, right? So I've got all this data coming back to me. And in this case, we're concerned with HTTP connectivity. So I would say, okay, if there's new stuff coming into HTTP events, I want an alert. And I'll give it an event code, JA3 meterpreter. Then I'll add a filter saying, if the JA3 fingerprint is equal to whatever fingerprint we're investigating right now, right? So if the JA3 fingerprint is equal to that, I want you to create an event. And when you configure these events, you can give the tags. We support the MITRE attack framework. So if you specify the tactics or techniques that relate to that type of activity, you simply specify that here. And what's going to happen is when these alerts are triggered in the future, it will show up in the EDR dashboard that has that it maps all the different alerts against all the different tactics and techniques in the MITRE attack framework. So you can see here one of our test VMs has generated 2 alerts of these 2 techniques, right? So anything that you create custom, as long as you use the right tags for MITRE attack, it would show up in there. And so I'll go back here. I'm just going to show my event rule that I previously created. So I had created one just like I was showing on this fingerprint, which is the version of Firefox that I have right now, because I figured that's a good way to generate some alert. But what's really interesting about this is you can use this for more than malicious JA3 fingerprints, right? So on workstations, people will have a lot of different TLS clients, right? So what you might want to do is from time to time, you might want to count them. Just go back here. And so because everything that we do is based on SQL, it's really easy to count the different fingerprints that are in use, right? So here you can see that in our global database, this fingerprint was seen over 2,000 times on this machine, and this one 390. And you can actually run that on your entire fleet, or you can run it on just your workstations, just your servers, or whatever. And then you can create lists of things that you know are not malicious. So you can create lists of known good JA3 fingerprints. And then if you're in a very restricted environment, you could say, alert if anything is not in this list, right? You just create a list and you say, I want an alert if something is not in this list. And then you create a list of bad JA3 fingerprints. You can say, I want an alert if anything is in this one right here. And the interesting thing is you can do that, and it doesn't require understanding exactly the data that went through in these encrypted connections. And so it has less impact to the user's privacy. You'll probably notice that in our HTTP table, we also have a other headers field, and we did that for privacy purposes. By default, we only get the headers that we need to compute the JA3 fingerprint. But if you want to gather more, you can, but it'll show up in these other headers. And by default, we don't grab any of that. We don't want to be getting session cookies, for example, from our customers into our database, unless the customer has specifically opted in to have these headers in there. And so once the alert has been created, what it would look like is you would get an alert, on this specific JA3 hash in this case, and there's 9 different instances of that. And for every one of our alerts, we can specify what metadata we want to see show up in here. So in this case, I just figured the JA3 hash was an interesting one. It's kind of an IOC, but I can also look at the alert context and see what else happened on that machine that at around the same time frame that could be related. And so I see here that there was a process or script acting as remote access software. So that's MITRE ATT&CK T1219. And if I look at the time, that's about 10 minutes before this JA3 hash was detected. And so you can investigate this, see what alert generated that, and it becomes really powerful when you link all of these together. And if one of these alerts, for example, was linked to a specific PID, in this case, I have an alert that's more fleshed out, right? So this is an alert that could have been triggered by JA3 as well. Then you can do things like see the process tree for that, right? So in this case, we have a text file that generated a PowerShell that was then executed. That looks kind of suspicious, right? And if any files or socket events were modified, we'd see that in the process tree as well. So you gain a lot of capabilities to investigate, even though you don't necessarily have the network visibility on these machines. And to give you an idea how fast these alerts are processed, we're talking a few seconds from the activity occurring on the machine before it's in our alerting pipeline, right? So something happens, you'll know a few seconds later, it'll pop up right there, and then you can link that to whatever platform you're using, or you can manage the alerts directly on Uptycs itself. And to make things even easier for you when you're investigating, we're adding a feature. This is live for a few of our customers, and it's going to be live for everyone this Monday. For types of metadata that are common, like JA3 or the SHA-256 hash of a process, when you click on it, then you can trigger pivot queries, right? You can say, okay, is this a file that we've seen elsewhere? Has this been seen elsewhere in my environment? And if any of that has been seen before, you just pop these up, and as you're investigating, you'll see all the metadata that relates to these queries, and you can take notes directly in there as you investigate, right? So you could click on a JA3 and say, okay, I checked this out. This is just Firefox. There's no problem with that. And this data is going to get saved with your alert. So let me just go back to my slides right now. Here it is. So a few other ideas for your remote workforce is to really ensure that your security and compliance tools are cloud-based. So an interesting thing with Uptycs is due to all the data we get from our version of OS Query, we're able to let you use this not just for security purposes and threat hunting and investigations, but also for compliance. For example, if you have to be PCI DSS compliant, or if you're doing CIS benchmarks on all of your endpoints and they're out and about, then you're already getting that data back in that same cloud platform, so you can just use our different reports for that. I highly recommend eliminating VPNs in favor of reverse proxies and zero trust type of solutions with multi-factor authentication. And really what you want to do is review the portfolio of the existing solutions that you have and make sure that it's still as effective for everything that's out of your network perimeter. So that could be remote workstations, could also be things running in the cloud, right? And the tool I really like using is the Cyber Defense Matrix, which I put right here, which is a tool created by Sunil Yu to make sure it's got a lot of different use cases, but one that I like is make sure that your portfolio of security tools provides good coverage without creating overlap, right? Like you don't want to be spending all of your money on protecting devices, for example, right? If you make a lot of software, your software vendor, you probably want to be sure you're protecting applications as well. You probably so you want to have good coverage across the board here, while making sure that that coverage still works for a machine that is not in your network environment. So I'm just going to go back to my demo environment right here. So a little while ago, we just ran that that command that was Dave's piece of malware that was generated, and 70. Oh, so this is when I ran it earlier. Let me just sort by time. There it is. So as you can see, there's about a 5-minute delay on the pipeline for seeing this data. Unlike our alerts are pretty much instant, but if you want to be selecting this data, there's a few minutes delay. And as you can see, this is still making steady connections to this host, which we determined looked suspicious, and it's using that JA3 fingerprint. Now, if I just take that fingerprint and I copy it, and I just search for it on Google, you see that in this case, that's a very well-known fingerprint. It is the fingerprint for MetaPreter. You saw how I created that MetaPreter. It's a very obvious fingerprint that people have seen before. In fact, it's referenced in the Salesforce article about JA3. They show that as an example. And there's many different sources for that. In fact, you'll see that VirusTotal is starting to have JA3 data for different payloads. And so it makes investigating really, really easy. And it's something that is so unique that I love using it for different purposes. If you're using containers, I would say that that's also another great use case, because containers are immutable. And so you know exactly which, if there's any TLS client in a container, you know exactly which. So you can create a lookup table in Uptycs or whatever tool you're using to monitor your environment, and look for a JA3 fingerprint that's going to be different to what you're used to seeing. But now, I know there's something suspicious there. What can I do to know what really happened? So what I can do is open up a query right here. I'm going to select from our process events on that machine. And we get a lot of activity. We get process events, we get socket events, we get a lot of different activity on machines, and that's being streamed to the cloud, right? So if I was investigating this, I could really easily see that, okay, Firefox is being used, and well, there's a lot of activity here, but eventually we would see these different commands being executed by me, such as one of them was called, okay, so I don't have this one yet. Oh, we see the command lines right here, right? So you see I just made Dave's app executable, and we see that it's actually there's a Python script that generated that. So as you investigate from one step to the other, it's really easy to know exactly what went on, because we've got the process events, we've got the socket events also. So all these processes, when they make where they make different connections, we're going to have that right here. So what is interesting with that is you see which path has made these connections, so you can know exactly what process made these connections. So now you had that JA3 hash, and now you can see exactly which process connected where, right? So this is the Ubuntu Network Manager, and so if you investigated for for a few minutes, then you would know which JA3 connected where, and it gets really easy to connect the dots. Now, I have a question here. Does this solution fit somewhere in the, I don't know if people pronounce SASE or SASE, S-A-S-E, Secure Access Service Edge. So where does that fit in that ecosystem? So everything that we do at the Uptycs, everything that you see in the UI here, we've got APIs for. And the idea is everything that I'm selecting here, the alerts, the configuration, everything is accessible via open APIs. So if you had a Secure Access Service Edge platform that is able to be integrated to anything that has web APIs, then what you can do is you can select information from machines. Right now, I was mostly showing things that relate to activity, right, like socket events and process events and all of that. That being said, with all the tables that we've got here, you can gather pretty much everything you want on a machine. So for example, we've got browser plugins, we've got Chrome extensions. Maybe you only want to grant access to people that have some official Chrome extension that you use for web authentication. That's only a query away, and these queries can all be exposed via the API, so you can integrate it with that, just like you could integrate it with different security orchestrators. We've got built-in integrations with Demisto, for example. And so whenever an alert is triggered, these same APIs are available. So you can use our Demisto integration to say, okay, a suspicious JA3 was detected. I want Demisto to connect to the machine and actually grab the executable that had that JA3 hash and send it to my sandbox where it can be analyzed. So integrations with pretty much everything are possible. So we've got about 8 minutes left for Q&A. If you have any questions, please feel free to submit them using the GoToWebinar tool. Make sure you send it to organizers, and then I'll be glad to answer them. So I have a question here, which is, would an attacker be able to create malware that would have the same fingerprint as, say, Chrome or Firefox? Yes, absolutely. Like a lot of things, it's not 100% foolproof. That being said, we've got two things up our sleeves that will really help with that. So one of them is we just want to make the attack more complicated for the attacker, and we succeeded if we force them to do something custom like that. Now, if you're looking at your own approved browsers, you can detect things that vary from that. And also browser vendors update their browsers pretty often, right? If you have got Chrome or Firefox, you're always pushing the most recent one. These fingerprints will change. So at some point, you might actually be looking for fingerprints of outdated browsers, right? Like that can be useful for vulnerability management as well. And then you could detect some of that malware. But the real fix for this is it's also possible to do JA3 of the server side of the equation, right? So if you remember in the beginning, I was saying we were fingerprinting the client hello packet. But there's also a method called JA3S for server, which does the same type of fingerprinting for the server side. And the idea is the command and control server combined with the JA3 fingerprint of the client becomes a really, really high quality indicator. So we're working on adding JA3S support to the HTTP events table in OS Query. We don't have that yet, but that should be coming soon. Are there good databases of JA3 fingerprints? Abuse.ch has one, and there's another one called JA3er, JA3er.com that has some good fingerprints if you want to get started and build a database of either legit or malicious JA3 fingerprints. Okay, one more question. Are there places where you would recommend doing TLS decryption instead of doing this kind of stuff? Yes. So I think TLS decryption definitely has a purpose, but I think its purpose is more for highly controlled environments where you have a high level of control and where the cost is not an issue, right? So if you're someone working at a big investment bank, for example, yeah, there's definitely environments where you need to have full packet capture of clear text traffic. That being said, this is really like a last resort option. in my opinion, because of the cost, performance issues, privacy issues, but also I feel like it's creating a like a single point of failure for confidentiality of that data, right? So imagine someone is able to break into one of your network devices, and that network devices is actually able to read all the traffic coming from all of your endpoints. Well, that's not great. And we've seen this, like the last few weeks are a good example. There are exploits in the wild for really highly critical vulnerabilities on network devices. So it's a point of failure that I don't like having to create. I've done it in the past. And honestly, if you're using like a next-gen firewall and you're putting too much faith on detection there, well, if you use the TLS decryption features it had, it would improve its value. But that being said, its visibility is still going to keep going down with things like TLS 1.3, making that more complicated, and people working from areas where you don't even see the traffic. So I hope that's a kind of a long answer to say, yes, there are some places where it's useful, but you have to be very careful with that. I think that was all the questions that we had. So I would like to thank you for attending this webinar, and I would like to mention that there's a big Windows DNS vulnerability that was revealed last Tuesday. Microsoft released a patch for it. Check out the Uptycs blog if you want to know exactly how to identify servers that might be vulnerable using OS Query, because there's a patch, there's a workaround. So just before I got on the webinar, we finished a draft of that blog post, and I assume that it is live by now. So I would recommend that you check that out. And if you're interested in getting a live demo of all the features in Uptycs, not specifically focused on TLS fingerprinting, feel free to visit our website. And thanks a lot to all the attendees for joining today.
All right, thank you. That's all the time that we do have for today. And thank you to our speakers, Guillaume and Dave, for your great presentation, and to Uptycs for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.